Yeah.
Yes, sir. We can proceed now, sir.
Yeah. Okay. 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 So, first of all, good afternoon to all. This is I am I Chinna Pandi. I passed out in 1995 B Mechanical Engineering. So we can divide this session into three parts. The first part, I will give my introduction. The second part, we will go through the content. The third, we will have an open session to discuss whatever you want to ask. We can have a pre-discussion session. Okay. So myself, I am I Chinna Pandi. I passed out in 1995. Be mechanical engineer from our esteemed National Engineering College. So then I started my career from Coimbatore. I worked there for 2.5 years. Then I moved to Haryana in a multinational company. I worked there another 2.5 years. Then I joined this company, Usha Group of Company, in 2000. Since then, I am working. Meanwhile, I have visited few countries like Japan, China, Germany, Italy, Austria, especially for machine selection, for manufacturing machine selection and maintenance training. This is all about. I settled in Delhi. Now we can proceed to the main content, the presentation. The presentation is all about today, the predictive maintenance. The predictive maintenance, it itself says we predict something to take action before that. So we can move to second slide. Can you please? Yeah. So these are the content. First, we will discuss about the failure, what is breakdown, and the basic approach to zero failure, zero breakdown, and the principles behind the zero failure, types of maintenance, 10 approach to plant maintenance, 7 steps of plant maintenance, and these are the 7 steps, and the results. How when we are adopting this approach and methodology, and how we can get the result that we can see. Next. So this is what is failure. This definition is taken from the TPM. The TPM is a concept. It is designed and developed from by JIPM. It's called Japan Institute of Plant Maintenance. It's an institution in Japan. They define some principles and methods for maintenance, and they promoted all across the world. In India, most of the auto component manufacturing company, they generally adopt these principles for TPM. In South, in our state, we can say that there are many TBS companies. They got TPM like TBS Fasteners and many TBS Group, TBS Brakes India, and the industries, cement industries. So they adopt this methodology to improve to reduce the breakdown and to improve their performance of the maintenance team. The definition says failure is defined in Japanese industry standard, that JS, is being any one of the following changes to the machine. One is losing any of its specified function. It is simple language. If something is not performing, then becoming unable to achieve its specified performance. The machine is performing, but the rate of production is less. For example, if you want to produce, say, some component of these things, and it will be some things. If we want to produce a rate, for example, per shift, if you want to produce some 5,000 component, we are manufacturing, we are able to manufacturing 4,000 component, so we can say that the feed rate, it is less. And third point is becoming unable to produce products of a specified quality. Now the quality product, the machine has to produce specified quality. It should meet the quality standards. So these are the three cases when we can say the equipment went under breakdown or the equipment is under failure. Okay. The origin is, the literal meaning of the Japanese word failure is deliberate damage. In Japanese, they say that in any machine, any man-made item, it won't fail itself. It is deliberately done. What does it mean? It means somewhere somebody missed some action that leads to that failure. For example, if you are having two-wheeler or whatever may be the car or two-wheeler, we have to do it maintenance or servicing in a periodic way. If we failed it, then it can lead to a breakdown or failure. Or if a person is doing the service, is repairing, he is not performing his duty fully, or he missed something during his duty, that also can lead to a failure. That is the meaning of deliberate damage, which means the equipment, what all the man-made item, it won't fail it itself. As a human, they fail to take some action, it leads to the equipment failure. Next, the basic approach to zero failure. So now the manufacturing industries, especially all the hybrid in our automobile industry, we have to continuously operate the machine 24/7, because in the manufacturing, in the assembly line also, they won't stop. If it is a totally automated line, they will not stop for the equipment. It has to continuously run it. So to continuously run that, what are the system we have to put in place so that the equipments are in good condition and it gives the optimum performance. So that the basic approach is equipment does not go wrong itself. People made it go wrong, that we have discussed earlier. By changing the way people think and act, equipment can be made completely failure free. So it's a mindset. Basically in Japan, I have attended many trainings in Japan at a different form. So even it is organized many, I attended in CII also in India, Confederation of Indian Industries. So they say we have to follow the system. If something is written, something has to do, that we have to follow that. That is all about maintenance. There is no shortcut. Nothing more, nothing less. Just follow the systems and the procedure. And the zero failure is all about the mindset. If we want to achieve, yes, we can achieve. That is the what one we should have a mindset, because generally what how we approach, if there is a equipment, one day it will go fail. That kind of mindset we adopt generally. But we have to change the mindset. That's what the thought. We have to believe in that. Definitely we can achieve zero failure. Okay. Next. The principle behind zero failure is bringing hidden equipment defects to light and nip up in the bud. Breakdowns are only the tip of the iceberg. The failure can create dust, rust, contamination, wear, loosen, rust, and excess heat. So these are the causes of the failure. So the principles of the failure, the behind the failure is, when the equipment is made, it is designed in a such a way it should not fail. So, but we are putting in a place where the operation, that the functioning of the machine is happening, then there, what is the condition? Are we giving adequate environment, and what is the ambient temperature, and what is the dust level of the shop floor, what is the illumination level of the shop floor, then whether the equipment is giving some abnormal noise or some vibrations to nearby area. These all the things affect the equipment. So what we have to do is we have to understand the basic first to achieve the zero breakdown. Next. So these are the types of maintenance. The maintenance starts with the breakdown maintenance, corrective maintenance, preventive maintenance, predictive maintenance, condition-based maintenance, time-based maintenance, and maintenance prevention. So the earlier age in 1960s or 50s, they used to do a breakdown maintenance. When whatever the breakdown comes, they immediately fix it. Then it moved to breakdown maintenance to corrective maintenance. If a breakdown occurs, they fix it. Then they do some correction, it should not happen again. Then it moved to preventive maintenance. Preventive maintenance, as they made a schedule for yearly, monthly, quarterly. These are the checkpoints we have to do. These are the spare points we have to replace. This maintenance called preventive maintenance. Then from that, they moved to predictive maintenance. That is the subject that we are touching today. The predictive maintenance, the word itself is saying we predict something before it fails. It gives the indication it is something happening abnormal. So at that time itself, we can take some action. That is predictive maintenance. That is what we are discussing today. And from predictive maintenance, we move to corrective maintenance, condition-based maintenance. Condition-based maintenance means we just see the condition of the equipment and we take some feedback of the condition. Then accordingly, we do some correction. That's called condition-based maintenance. And the time-based maintenance is as good as preventive maintenance. The timely, we have to replace something. So, for example, we put this is a 2000 running hours, or you can say 2 years or 6 months. These parts we have to replace. So we have to replace that part. That's called time-based maintenance. And another, the last method is called maintenance prevention. Maintenance prevention means during design stage itself. So, for example, if we are using one equipment, so when a new equipment we are planning to buy, that time itself we ask the manufacturer to modify the design so that that failure will not happen. That is called maintenance prevention. So these are the typically 7 type of maintenance. Next. So this is the basic role division. It means when there are manufacturing team, they are producing, they are operating the machine, and there is a maintenance team who is maintaining the machine. So the role we have to define what are the things, what are the points the maintenance team will take care, and what are the points the maintenance manufacturing team will take care. This is the role definition basically. Accordingly, when the operating maintenance in charge, they give the check sheet to the production team, production in charge. These are the points they have to check in everyday operation, and they have to give feedback according to the maintenance team. Next. So this is the main crutch of this content, whatever we are discussing. How a plant, a industry can go zero breakdown. This is the methodology which is defined and developed by Japan Institute of Plant Maintenance. This in the name of TPM, that's called Total Plant Maintenance. This is a 10 approach of plant maintenance. This 10 approach shows how we can increase the availability by increasing MTBF. MTBF means mean time between failure. For example, in equipment fails today, and it can fail after 1 month also, after 6 months also, after 1 year also. So there is a mean time between failure. And the another one is a reduce MTTR. MTTR means mean time to repair. For example, in a shop floor, we are having 6,000 machines. There are having 500 breakdowns, and it took 1,000 hours. So 1,000 divided by 500 is 2. So it means mean time to repair one breakdown is 2 hours. So this is how we can get to achieve that. These are the 5 things we have to do first. One is a 7 step of plant maintenance, then guidance and supportive distribution, then corrective maintenance and maintenance prevention, then different techniques adapted. Then the second point is maximize machine efficiency. For that also, these are the actions. So when you put together these all 10 actions, so we can achieve a plant as a zero breakdown plant. Next. Now, these are the 7 step of plant maintenance. So the first step is analyze the difference between basic conditions and current situation. What does it mean? We have to check the basic current condition of the equipment. The next step is correct difference between basic condition, ideal conditions, conditions are in current situation. So now once you identify it, the difference between basic condition means the condition of the machine where the supply is supplied to us. That is the basic condition. Okay, so we have to correct that to bring back to the basic condition. The third step is establish standard for sustaining basic condition. So what does it mean? Establishing the standard, which means we have to define some checklist. So what are the checks? As we discussed earlier also, what are maintenance has to be taken care, and what are the checks taken by the production guys, those who are operating the machine. So we have to make a standard. These are the standard. Then the fourth is extended working life of equipment and eliminate weakness. Now, what does it mean? Extended working life of equipment means, for example, if a spindle is working for another 10 years, so what we have to do after 10 years, whether we have to replace the spindle or rectify the spindle so that it can work another 10 years. And if we find any weakness on any part, that we have to replace. That is the fourth step. Then rationalized checking and servicing means whatever the checking and servicing we define, that we have to religiously follow it. Then perform comprehensive equipment diagnosis. Here it comes the predictive maintenance. So we have to install some equipment, some tools and tackles on the equipment so that it can give us continuously 24 by 7 feedback. Accordingly, we can take action. So if we take all these 6 steps, then we can maximize the equipment life. So these are the 7 steps. So once we are adapting or following these 7 steps, so we can achieve that zero breakdown. Next. So this is the first step. So what we discuss, analyze the difference between basic condition and current situation. So how it is in a shop floor, there are different machines. For example, rough tanning, locating seat, fine boring, grooving. There are different machines. So we just check the number of breakdowns, but in a month. So we mapping it. Once we mapped it, then we select which are the machine is contributing more. That is for the selection. That's for the analyzing the different between basic condition and the current situation. Next. And we put it in a 2D matrix. The 2D matrix it shows which component it's fail or which equipment it is failing. So we take that in a particular machine, is it the machine is going again and again breakdown, or it's some particular component is repeatedly going breakdown. So this is the selection mode where you to work on in a particular machine or on a particular component. It's called the 2D matrix. Next. Then we do some YY analysis also. These are the YY analysis. Why the failure is occurring. For example, if air pressure is low, hydraulic pneumatic device, then why? Booster not working. Why? Air leakage from the cylinder. And why it is failure? The rod seal worn out or air pipe burst. The why? The last thing, we have to take countermeasures. In countermeasures, there are 2 countermeasures. One is physical countermeasure, another is management countermeasure. In physical countermeasure, we correct it. What are the things we are replacing or what we are doing it. And in a management countermeasure, we take action so that it will not repeat again. The failure should not come again. So 2 type of countermeasures. One is physical, another is the management. Next. So this is the correct basic conditions identification. So whatever the failure is coming, it is a tip of the iceberg. So before it fails, there is some hidden parts inside the equipment. It can create or it can make the equipment fail. Next. So this is one thing we call it the record sheet, failure recording sheet. In this record sheet, we make what are the components go wrong. For example, defective lubrication, defective operation, defective checking, or overloading, or a foreign particle, or stress concentration, defective repair, defective installation. So this is the recording sheet where whenever any equipment goes fail, so we fill this record. Once we are filling this record, we can come to know that what is the root cause. With that root cause, we have to take analysis. So this is the maintenance report how we maintain to identify and what is the cause of the failure. Next. And these are the things we will identify the cause, the root cause, whether it's the primary cause, other is the secondary cause, and what is the countermeasure. For example, hydraulic or pneumatic device, cause code is incorrect equipment selection, selecting the wrong specification, deterioration over time. There is no equipment inspection standard. So when we find the primary cause, then what could be the secondary cause? Equipment control standard are not there. So if it is not maintaining, if the check sheet is not there, the operator is not checking that, the function of the individual component, It may be the standard not provided with the manufacturer, or the maintenance in charge did not prepare the standard. The countermeasure equipment control standard has to be prepared, and accordingly we have to check it. So this is the primary cause, secondary cause, and countermeasure. Next. And this is the identification of equipment if any part failure happens. So we will identify, we will check some according to some standard. What should be the actual, and what is whether it's okay or not okay. When it's not okay, there we plan for corrective preventive actions or countermeasures. Next. The same thing, that is for tile stock, and this is for coolant pump. Next. And this is the mapping. So once we identify a different part, the whole equipment, we identify we do mapping to understand what are the components, the defects happening, which are the areas. For example, tail stock, spindle, chip conveyor, coolant system, turret noise. The whole equipment is mapped. So where are the failures are happening, and what are the failures, and what are the code. So this is mapping. It helps us to take action. Next. This also the same things. Once we prepared that, then we check who missed it to check it, whether the responsibility is maintenance team or the responsibility is a production team. Then what is the frequency we are defining to for the checking point. Next. And this is the what are the these are the indicators we provided to operator to check whether is the pressure gauge it is green or red, and whether the direction is okay or not, or the level indicator is the oil level is within the range or not. So these are the indicator, visual indicator provided to the operator so that he can check it and he can maintain the basic equipment. Next. Then comes to the step 3. It is establish a standard for sustaining basic condition. So this is the standard, how we maintain the standard. So we prepare the annual schedule, and the annual schedule, the standards are maintaining. They will check if it's a monthly means monthly, they will check it. If it's okay, they will put it okay. If it is not okay, they will take the actions. Next. And these are the standard sheet, how they will actually check it. For example, if the spindle axial play is less than 6 micron, he will check it how much it is. Axial play, radial play, parallelity, perpendicularity. So these are the check sheet why the carried out used during preventive maintenance, or they are carrying out the preventive maintenance. Next. And these are the checkpoints, standard checkpoints, which helps operator to maintain the machines. Basically, it's the pressure, how much, what should be the pressure, and what is the control parameters, what are the control parameters he has to maintain while operating the machine. Next. And to extend the life of the equipment, once we identified what are the parts giving repetitive failure, so we take corrective action. Once the corrective action is implemented, the breakdown will be eliminated. So that is why we focus on the component level and the equipment level. If the equipment is continuously failing again and again and again, we have to take equipment and we do some corrective measure action. And if a component is failing, we take the corrective action on the particular component. To identify that, once the corrective action is taken, we use the diagnostic techniques to predict that. What are the diagnostic techniques? We will see the subsequent slides. Next. Go next. Yeah, this is the Kaizen sheet. Kaizen means basically in Japanese word, it's called improvement. So whenever we are doing some improvement, so we make this sheet, Kaizen sheet, then we give it to the manufacturer so he can incorporate with the new machines. Next. This is the rational checking. How we check it? The spindle radial runout or parallelity, perpendicularity, how they check. during operation. So if anything is going beyond that limit, we will correct it to maintain that standard. This is a rational checking and servicing. Next. This is the schedule part replacement plan. So once we have done this, all the correction, when you establish the standard. So after that, we do a mapping. So for example, in a spindle, it can run only 5 years. So after 5 years, it is giving problem. So we will map it. So after 5 years, this has to be replaced. And some of the component in the 6 months, in 1 year, in 2 years. So the mapping we'll do so that before it fails, we can replace the component. That is the rationalized checking and servicing. The purpose of rationalized checking and servicing. Next. And these are the tables which helps you to identify what are the components to replace on a periodic time. For example, indexing table, part sensor, misactuation, ingredients of foreign material, robust metallical standards provide to place of plastic or. So these are the preventive action we take for the individual components. Next. I think this slide is repeating. Huh? Okay, next. Go next. Yeah. So this is the basically when whatever we are talking about, the predictive maintenance comes here. So far we have what we have done it, the basic maintenance, we progressed the breakdown maintenance. So we mapped the machine, we identify the equipment, we identify the component, then we corrected, then we made a standard, then we made a preventive maintenance plan, then we prepared a periodic replacement plan, then we prepare a standard for checking. Everything is done. Now the equipment is working well. Now these are the diagnostic tools we incorporate along the machine so that it can give indication before it fails. The vibration check instruments for spindle. So most of the equipments are running with a spindle. In automobile industry, 99% of the machine is equipped with a spindle. Spindle means where the component is clamped and the tool machines to get a desired output. So in every spindle, we put a sensor. This sensor gives signal. We can take it in our mobile also, in our laptop also. So we feed it the different color zone, green, yellow and red. So if the spindle is running within the permissible limit of the vibration, so it shows the green. And if it goes beyond that level, then it gives yellow. That the program is like that. Whenever any, so if you are having 500 equipments running in your shop floor, it is taken into your that is industrial 2.0. That it is taken into your mobile. So what would any equipment? It's going beyond the level. It gives one signal like a message indication. It will give you gives it triggers you so that this equipment is going something is going abnormal, it's going beyond the specified limit. So that we can immediately come to know that we can plan it and stop the equipment, correct it so that it cannot damage further. So this is called spindle vibration. Spindle vibration, spindles are supported by bearings, and if the bearings, any abnormality in the bearings, then only it vibrates. This is the one is the vibration, and the another is the temperature. So some of the equipments we install the temperature monitoring, it goes beyond the temperature. So that also gives. Then it gives some thermal mapping and some noise monitoring also installed in some places. So if any, for example, DG sets, so if the noise also exceeds, so it can give a trigger. So this is all about the predictive maintenance. The predictive maintenance is carried out depends upon some tools. That tools gives us as a input if any specified limit is crossing. From that point, we can take action to avoid the failure. So this is all about the predictive maintenance and the predictive maintenance tools. Next. And these are the tools where vibration monitoring, spindles, bearing condition monitoring, spindles are monitoring, compressors, rotors, electrical bus bars, and breakdown voltage of transformer oil, transformers, motor current and resistance, spindle and hydraulic motors, winding insulation resistance motors, corrosion rate, process water pipeline. So this area is really the crutch of the predictive maintenance. So these are the instruments which basically gives you off the line the condition of the equipment. From that, we take action to avoid the failure. So this is all about the predictive maintenance. Next. This is the example of how we can do that green, yellow. It shows, gives the feedback like this. Okay. Next. And this is the same. We can define in some of the component also critical to quality. So if it is one is the equipment part, the equipment is even though running, and some of the parameter, the quality parameter also we have to take in there. There we put some specific instruments to identify whether the quality is going beyond the limit or not. For example, see if the vibration system, it gives the vibration, the spindle. But there is some other thing, it gives the quality of the product, for example, cylindricity or a run out or surface finish, like that. So that also we can use as a predictive maintenance tools. Next. And once we are doing that, where we can install the quality feedback instruments, that point we mark on the machine, there we install, so that it can directly, that feedback can directly taken for the quality point of view. Next. And this is the parameter comprehensive checking. We discussed the pressure gauge, level indicator, pressure gauge again as per work instruction, RPM indicator, pressure switches. So these are the instruments which gives you feedback, clamping pressure, set pressure, all these things. Next. And this is a standard wherever, for example, RPM, which are the machine we are using, the clamping feed where we have to maintain, spindle lubrication where you have to maintain. This is the mapping for maintenance standard, basically. Next. Yeah, once we are maintaining all these things, and these are the result. This is a very old presentation which we have given for TPM audit. Once we adopting all these 7 techniques, so you can reduce the taper down your breakdowns. Next. This also breakdown graph, a number of breakdown. When we started the TPM activity in 2016, it was 1579 breakdown, and we brought to 158 in 2021 H2. This is the number of breakdowns. Next. This is the hours. The hours is 3742 and it comes to 748. The number of hours breakdown. Next. This is the MTBM. MTBM means mean time between failure. There is a formula to that, mean time between failure, how to calculate. For example, in our company, there are 6,000 equipments are there. The 6,000 equipments, it runs for 24 hours and it runs for the whole month. So it is the available hours is 6,000 multiplied by 24 multiplied by 30 days and divided by minus breakdown hours. How much hours in a particular month you got breakdown and divided by number of breakdowns, which gives the total mean time between failure. Next. This is the MTTR, means mean time to repair, which means, as I said earlier also, the total hours is 1,000 hours in a month breakdown. And this is 500 breakdown in a month. So 1,000 divided by 500 to 2. It means in any breakdown, it took 2 hours to restore. That is the MTTR. Next. Thank you. This is all about the presentation for the predictive maintenance. And generally, how in an automobile industry like us, we are maintaining the equipment. It's basically we follow the automobile industry is mostly in India. They follow Japanese standard. because all the industry is there, Maruti Suzuki, Suzuki's collaboration, Honda Foundry, Honda. Even in my company, we have a collaboration with four collaborators, and two is from Japan. One is Honda Foundry Japan. You might be heard about Honda bike. So Honda Foundry Japan. We have a collaboration for piston manufacturing, piston foundries in Honda Foundry Japan. And Fuji Works, there is a company in Japan which supports the technical support to the engine valve manufacturing. And Kolbin Smith Germany, they are support for again piston manufacturing. And the ring component also Riken Corporation Japan. So these are the four principles. So the technology what we are using it from this support are trained in the overseas from our collaborators. Even myself, I went many times to Japan for the maintenance training as well as the equipment selection. In Germany, as I said while starting it. So generally, we follow the system adopted by the Japanese, and especially for the maintenance, we follow the TPM guidelines, and there is a certification also. Like I don't know whether many of you heard about or not that in quality they say a Deming Award, and for the plant performance it's a TPM. They say the TPM total plant maintenance. That is the award. It's a 5 years journey, like a course when we are doing engineering 4 years course. That also 5 years course. That's why I in my presentation also you might be seeing that we started it some years back. That as a benchmark. So we taper down to after 5 4 years. So when you adopt the methodology, because it's not you can achieve overnight, it takes a lot of time. Understanding the basic condition first, then eliminating the losses, then doing corrective maintenance, then preparing for the standard, then putting diagnostic tools to predict the failure. So it is not one go. We can apply to all the 6,000 machines. So first we select 100 machines. We adapt, we install those predictive tools on those machines. Then literally parallelly horizontal deployment, we achieve some state. The maintenance itself, as I said earlier, the Japanese, they have a different principles and philosophies, totally different from us. We generally what we think that any equipment it can go fail at any time, but their mindset is totally different. They say the equipment won't go. It is their definition itself says it is a deliberate damage, because any equipment it won't go fail. It never fail. A man made it fail. Like accident theory, when you are acting in a third year student, you might be studying accident theory. When I was in our college in third year, there is a chapter subject called industrial safety. In that is a theory. Theory is there that accidents do not happen; they are caused. Even I do remember this sentence, which I learned 30 years back in our college. The accidents do not happen; they are caused by the people. Any accident in any world, it won't happen itself. A man missed to take some action at this particular point of time. He missed anywhere. That miss chance, that cause created an accident. Like that, equipment. Any equipment never goes fail. Never, never. It fails only when a human being he missed to do some action on that. So this is their principles and their practices. That what we are. It is very difficult to digest and believe in Indian context, but it's true. It's true. When we initially when I attended a training, I'll share one thing. When I attended a training way back in somewhere in 2002 or something like that, they gave a simple task to do us in a hall. They asked us to do assemble in a linear guideways. In a linear guideways, it's a lengthy guideways. There are some bolts, 8 to 10 bolts are there. So we have to tighten it. And they said how to tighten it. If it is 8 bolt, we have to start from one bolt to this side, another bolt to this side. Then we have to come on close to the center. And once we tighten, we have to tick it by the marker. And we went to hall and everyone is given the task to do that. So we started assembling it. So once after that, after assembly is done, then we went to the class, the theory class. They asked How many of you followed the steps? And everybody we said, yes, we followed it. And they shown the CCTV recording. They shown the recording. And no one is followed how they said. So what is the problem with us? That is the mindset that we learned it. That is from mindset. If somebody asks to do that, you tick this, we have to tick that. If somebody asks to do that, first tighten this bolt, we have to do that. This is all about maintenance. So now it is a complex world, and it is a very sophisticated technologies are available, and a very comprehensive diagnostics tools are available to predict the failure. However, it the cost effective. It won't be cost effective to do all these equipments by using to predict all the failure by using the diagnostics tools. The best method is to maintain the basic things as it is. So this is all about the presentation. So now I am open to you all. You can ask anything.
Sir, I have a question.
Yeah.
Sir, in predictive mode maintenance, does they implement the principles of failure mode effective analysis also?
Yeah, definitely. See, the failure mode analysis FMEA. Once you done the failure mode, once the failure when you identify the failure mode, you take some corrective action, then you take some preventive action. That is in a YY analysis. I said two things, two actions. One is a management action, and one is the corrective action. What is the management action? We do once it is everything's fixed, well, we analyze that whether can we put some predictive tools, a diagnosis tool fixed to that, so that it can trigger, it can give a trigger, and it can give information before it fails. Yeah, depend upon that. As I said, see, there may be a number of failures, and you can't go and take it for a predictive maintenance tool in all the failures, because there may not be a cost effective. Number one, and the number two, the failure. Why happened the failure? The first thing is why failure can happen. Failure can happen only when we missed something. And the accident theory, see, it won't happen. It is deliberate damage. Okay, and coming to your point, whether we can use the failure mode as a predictive tool, yes, we can use it. Once the failure mode happened, we took a corrective preventive action, and we can eliminate. We can use a predictive tool, and we can, during the manufacturing of the equipment itself, the manufacturer can also give you a predictive tool. However, there is a cost to it, and he will charge. If the equipment we are buying by 1.5 crore, and if you ask to put them all the predictive tools, he may ask another 50 lakh also. So that is the thing where it matters. Yeah. Next. So you all are a mechanical branch, right?
சார்
You all are
உங்க
mechanical.
இண்டஸ்ட்ரியில நீங்க மேஜரா ஃபேஸ் பண்ற ப்ராப்ளம்ஸ் என்னென்ன சார்?
See, நாங்க மேஜரா இண்டஸ்ட்ரியல் ப்ராப்ளம் ஃபேஸ் பண்ண ப்ராப்ளம்னா குவாலிட்டி ரிலேட்டட் தான். குவாலிட்டி ரிலேட்டட் நம்பர் ஒன், and the number two, of the budgeting, the cost is the main problem, because maintenance நம்ம வந்து எவ்வளவு நாள் மெயின்டெனன்ஸ் வந்து மெயின்டைன் பண்ணலாம், பட் there is a cost to it. நம்ம எல்லாத்தையும் ரீப்ளேஸ் பண்ணிடலாம், எல்லாத்தையும் வந்து பிஃபோர் இட் ஃபெயில் வி கேன் ப்ரிடிக்ட் பண்ணிடலாம், பட் how the maintenance model works, that's different. The மெயின்டெனன்ஸ்க்கு எவ்வளவு பட்ஜெட் அலோகேட் பண்றாங்க, that is the main thing behind it. If you have a sufficient budget, then you have a skilled manpower, then there is it won't happen failure. Then coming to your exact point, what the problem we are exactly facing in our industry. In our industry, the mainly the budgeting is of main industry thing. Second likely will be the attrition, the skilled labor keep on moving that. So the developing another, that is the main problem. And ultimately the management will take care, pump the manpower accordingly, so that due to the maintenance failure, the production target should not fail. That's the main motive of the company. Yeah. Next. You all
So I
are
think no more questions from the students, sir.
okay. So we can have a open free talk also. So how you guys are planning your career? So how many of you are what I can say that you might be having a different task in your hand. You know, you all are third year or final year.
Sir, mixed from all the departments, sir. Second year, third years, and as well as final year students, sir.
Only mechanical, no? Huh? Mechanical. Huh? Yeah.
Only
See,
mechanical, sir.
mechanical. See, the mechanical, I'll share my experience about how a mechanical engineer can progress in his life. See, mechanical engineers has to be more laborious, number one. Laborious means what I say, what I mean. We have to work hard, harder than the hard, tougher than the tough to achieve something in our life. It is not like that, yeah, techie, yeah, IT professional. Even many of the mechanical engineer also can change to IT professional. That is, I'm not touching that part. Even in my batchmates, most of the it may be hardly less than 10 people out of the whole branch. 10 people might be in working in a mechanical field, and the most of the people are in a software industries, and there most of the people are settled in abroad in very in our in my time there was only three branches: computer and mechanical, and computer mechanical, and electronics and communication. Only three branches in 91 in 91 when we joined. In the 95 when we passed out, there are triple E came and the civil came, something came like that. Okay, so in that time the software was boom. When we passed out from college, everyone joined some course of computer and went abroad and they are settled. But now the situation is not like that. Now the situation is the different. There are so many engineering colleges and so many IT professionals also already there. So as once we take a mechanical, so what we can how we can progress? Or somebody might be thinking, some of you might be thinking also to shift to IT also. And I'm telling you, those who want to be stick to the mechanical branch. So those who want to start as a mechanical engineering career in any of industry, first you have to work like anything. Whenever you are getting opportunity and wherever you are getting opportunity, we work initially like anything to get hands-on experience. So once you get a hands-on experience, then the opportunity will you will get a lot of opportunities. But when we compare ourselves with yourself, with your computer techie guys, when you are starting your career, so your life may not be like that. Their life, what how they are enjoying it, how they are handling the things like that. So you have to be you understand and believe that you are in a hardcore track. This track it itself has some requirement, like the sum of hard work. You have to work hard. You have to dedicate your time like anything, more laborious, and with the respect of what the salary you are going to get. When I started in 1,500 rupees per month salary at in Coimbatore. In most of the friends like that only in Chennai, many of them stayed in Chennai. They started going for coaching for software industries, and many of them worked in a different companies at a salary of 1,000, 1,200, 1,500 rupees salary per month. So from that, we kept on moving like that, and gaining the knowledge and putting hard work. So it's elevated in a different scale. That that thing you have to set in your mind. That's one thing. If you want to ask me, if you want advice as a mechanical engineer, what I can suggest you to this: if those who have decided to continue as a mechanical engineering field throughout your career, and you have to do hard work. You have to build yourself, your identity to any industry. They will give you opportunity at the initial stage. From that, you can pick like anything by your hard work, your dedication, your determination. For that, you start from now onwards, wherever, whichever your year, 2 years, second year, third year, and final year, you just set your mind. Have a framework in your mind. Yes, I want to be this mechanical career, so that I have to work the industry. Try to visit some industry if possible. If anybody want come to visit the industry in here also, in north also, I can arrange for you. Or anybody want to do training,
internship training I can arrange in my company also, here also. Or we have a company, one company in Coimbatore also. We have four companies for this product. As I said, one is Indore, Madhya Pradesh, one is in Rajasthan, one is in Delhi, and one is in Coimbatore. That's for only electrical vehicle components. So try to go in some industries and work hard and learn these things. Mindset, set your mind. That's the one thing if I want to suggest you. Set your mind, fix it yourself. Yes, yes, I want to be in the mechanical engineering field. So accordingly you move. That's one thing I would like to suggest to all of you. That's all about from my side.
Thank you, sir. Thank you so much, sir. You have shared a lot of insights to our students today. Even in your busy schedule, we know that you have 6 days of working in your company.
Yeah, yeah.
So
Still
thank
I'm
you
in the
so much
company.
for spending your time
Not
for us, sir.
okay. So this is all about, and you have my number, my email ID. Any want any help at any time. If I am unable to pick your call, definitely I will connect you later. Any one of you. Those who are joined also, those who are not joined also. Okay.
Okay, sir. Sure, sir. Thank you,
Okay.
sir.
Okay. Thank you so much. Bye bye. Okay.